Hi, my name is Christopher Henry. I'm in Corin Rumbach's Fundamentals of Physics class. I'm doing an experiment today based on the second law of thermodynamics, the law of entropy. For some safety issues involved in this experiment, I am using tongs to remove my cans from heat sources. I have one that's in a boiling pot of water and one that's located directly on the eye with water inside the can. So we're going to get probably two different results, if not probably the same result. Since there is a heat source involved, I have a fire extinguisher standing by just in case some kind of fire breaks out. I have cleaned both cans to remove any other things that possibly could catch fire, but it's better to be safe than sorry. What we are going to do in this experiment today is I'm going to take these cans that have been heated up, and the water that's inside both of these cans will be boiling. It'll take the air inside of the can and basically increase its volume or increase its pressure. These cans will then be removed from the heat source and dropped into this bowl, which is basically just water with ice. Now the water inside of both cans should be roughly about boiling. They've been on the stove about the same amount of time. The water in the pot is actually boiling. The water in the can is already boiling. So by that logic, this should be boiling as well. Now the ice bath I've moved directly behind both of those. The fire extinguisher, again, is still off to my left in case something catches fire. Alright, basically what I'm going to do is I'm going to try the can from the pot first. It should basically crush itself. There might be a lot of noise and things like that, so you might want to keep children away from this type of experiment, as well as yourself if you're smart. Now, the one from the pot, as you can tell, did not crush. So I'm assuming that the temperature inside of the can had not actually reached a boiling temperature yet. Now, the one on the other side of the stove, that's been on direct heat, is boiling, and as a matter of fact, you can see steam coming out of it already. So now, with that being said, this can should crush. Now, because of the vacuum created inside of the can, it sucked water from the ice bath into the can. Not a lot, but a little. Plus the water that was still in there. And as you can tell, the can has been mangled into a mess. Now, based upon that, the information I have for you is when the water boils, it fills the can with steam, displacing most of the air that was originally in the can. When the can cools, the steam condenses back into a liquid, reducing the pressure inside the can, from which most of the air has been expelled. The surface area of the can is about 0.031 meters squared, and in the extreme case, a pressure difference from one environment, being the cool air around me, to the air inside of the can would apply a force of about 700 pounds, which is far in excess of what the can is able to sustain. The water, as you saw, did rise up into the can because of the vacuum created a little bit, because I think I did not get a flat seal on it when I tried to drop it in the water. The inertia and viscosity of the water actually inhibits it from entering the can in excess, which is why the can crushes itself, instead of just sucking the water up into it. Some water does spray up into the can, as you saw, and this water causes the steam to condense very rapidly, creating the two different pressures on the can. The pressure inside the can from the air is actually less than the oxygen or the pressure from the air outside of the can, causing it to crush very rapidly. Thank you, and that was my experiment for Fundamentals of Physics.